All right. So, in this video, we're going to start with this non-standard basis B of three vectors for R3. And we have this vector 1, 2, 3. And our goal is going to be we're going to find the change of basis matrix um, from basis to the standard matrix. And then we're going to show how to use this matrix to express V in terms of this non-standard basis. So for the first part, though, right? So from our definition, right, the first part of calculation, this is really just like assembling the ingredients in the right way. So from our definition, this change of basis matrix is the inverse of the matrix obtained by using the columns, uh, by looking at the matrix whose columns correspond to the vectors in B. So that's the inverse of that matrix, which I mean, in principle, is a perfectly valid description of it. But if we want to do anything with that, let's go ahead and do that additional step of actually calculating the inverse there. And so we'll do that by calculating a row reduced echelon form. Or at this point in our understanding, you can go ahead and just use octave right off the bat. But just to illustrate the expanded method there, so if I calculate that reduced echelon form, vertical line, and then I get 1 minus 7 minus 4 minus 153 and 1 minus 4 minus 2. So our final answer, right, this change of basis matrix is this guy here. All right. And because I'm going to need him later, let's go ahead and save that. All right. So that's the change of basis matrix. What is it good for? Well, this is the matrix that's going to allow us to transform any vector expressed in standard coordinates in terms of our new basis. That's the utility um, of this here. And so how does this work? Um, so here, right, the B coordinates of V are found by, that's exactly what MB gives us. So we just calculate MB times V. I'm going to copy our matrix there. We're going to multiply by the vector 1, 2, 3. And using technology to verify your answer, we get 2 minus 9 minus 4. So these are the coordinates. And so like we could stop here if all we cared about the coordinates, but just to really illustrate the utility of the concept here, right? The way to interpret this is that 2 minus 9, 4 minus 4 are the coordinates of vector v with respect to the new basis. And so as a sanity check, right, we could do 1, 2, 3. So really what those coordinates mean is going to be 2 times the first vector minus 9 times the second vector minus 4 times the last vector there. And so we've got, right, both sides of this equation represent the vector v. This is v described in terms of standard coordinates, and here's a different description for it if we decided that we wanted to use b coordinates.